Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will go through everything you need to know for your upcoming test. So there are two topics, directed numbers and shapes. So let's start with directed numbers. So we'll look first at a number line that I know you've seen before. The arrows at each end indicate that it goes forever. So sort of in the middle of the number line is the number 0. So 0 is neither positive nor negative. So to the right of 0 are all the positive numbers. So when we say positive number, what we mean is a number that is above 0. So we could put a positive sign in front of all these, positive 1, positive 2, but we don't need to. If you say like the number 3, it's understood that you mean positive 3 or 3 above 0. Now to the left of 0 are the numbers that are less than 0. So on the other side of 0, you still see the same numbers. So we have a 1 here and a 2 here. You can see that it's going in the other direction. So what I mean by that is, now the 3 is to the left of the 1, whereas on the other side you have, say, the 3 is to the right of 1. Now this would get confusing. So what we do is we put a direction sign in front of these numbers, hence the name directed numbers. So that direction line is this symbol here, which means negative. So these numbers to the left of 0 are negative. Negative 1, negative 2, negative 3. This symbol, the negative symbol, indicates these numbers are below 0. And we can keep going with the number line. So all of the red numbers are negative, they are below 0. So for example, if you have, say, a temperature of, say, minus 5 degrees, minus 5 is here, that means the temperature would need to rise 5 degrees to reach 0 degrees. So as you go to the right, numbers are actually getting larger and larger. So if a number here on the number line is to the right of another number, it's greater. So we know, for example, before you even watch this video, you know, for example, that 3 is greater than 1. So some people get a little mixed up with the symbol. Remember, crocodile eats the bigger number. This is the bigger number here, so we want to write symbol like a crocodile's mouth. So consider this like the mouth, and it eats the bigger number. This statement says that 3 is greater than 1. You already knew that. But I told you that when we go to the red side, to the left of 0, negative 3 is to the left of negative 1. So 3 is greater than 1, but it turns out negative 3 is actually less than negative 1. Once again, we want the crocodile to eat the larger number. This time the larger number is negative 1, so the symbol goes this way, like this. So the reason negative 3 is less than negative 1, think about it in terms of temperatures. Negative 3 would be colder than negative 1. If the temperature was negative 3, it needs to rise more to get to 0 than if the temperature was negative 1. So by a similar story, negative 7 is less than negative 2. If you look at the number line on the screen, negative 7 is to the left of negative 2. So as we go right, numbers are getting larger, and as we go to the left, numbers are getting smaller. So negative 3 is also less than 0, like we said before, because it's to the left of 0. Negative 5 is less than positive 2, because it's to the left. Now we can also use this number line to perform addition and subtraction. So to perform addition and subtraction using directed numbers, we need to follow these rules here in the box. To add a positive number, move to the right, and to subtract a positive number, move to the left. So you already know how to do something like 3 plus 4, and you know 3 plus 4 is 7. So why is that? Well, 3 plus 4 means you start at 3, and because we're adding a positive number, we go to the right. How many spots we go is the second number. So we start at 3 and we go 4 spots to the right. 1, 2, 3, 4. So 4 spots to the right, we end up at 7. So 3 plus 4 is 7. I know you already knew that, but let's do some now that involve negatives. So let's say, for example, I wanted to do negative 5 plus 8. So what I do is I start at -5. Now I'm adding a +8, so I go 8 to the right. 1, 2, 3, 4, 5, 6, 7, 8. I end up at +3. So I moved 8 spots because the second number was 8, and I moved to the right because I was adding. So -5 plus 8 is 3. So hopefully you will, if not already there, you'll get to the stage where you can do all these without a number line. So let's now look at a subtraction. So let's say now I want to do -2 minus 5. So what I do is the first number is -2, so I go to -2. Now I'm subtracting +5, so I go 5 spots to the left. 1, 2, 3, 4, 5. I end up at -7, so that's my answer. Okay, so in the test you can draw one of these number lines if you want. It's just good to be able to do without them because they take a while. So what about if we're adding or subtracting negative numbers? So to add or subtract negatives, we're now going to use the rules in this box here, and then we're going to use the rules above. So just before we go into these rules and see how they work, we've got this word opposite here. So the opposite of a number is a number with the same value but different sign. So what I mean by that is, like -4 and 4, they are opposites because they're both a 4, but one has a positive sign, one has a negative sign. The opposite of 3 is -3. The opposite of 27 would be -27, and the opposite of -90 would be +90. Okay, so they're in each case the same number, but a different sign. So we're going to use that to add and subtract negative numbers. So let's say I wanted to perform some -2 plus -3. So I'm adding a negative. So when I add a negative, I subtract its opposite. So what that means is I take -2 and just subtract +3. When you have a plus and a minus next to each other, they make a minus. So -2 plus -3 is the same as -2, so we'll go to -2 and subtract 3. 1, 2, 3. So we're actually making the number smaller. -2 plus -3 is -5. So now let's say I want to perform -5 minus -6. So here I'm actually subtracting a negative number. I'm subtracting -6. The opposite of -6 is +6. So this is -5 plus 6. So two negatives together make a positive. We already know how to do that. We start at -5 and then we go 1, 2, 3, 4, 5, 6 spots to the right, and I end up at +1. So -5 minus -6, I've actually ended up with a positive number 1. All right, let's look now at multiplying and dividing. Please pause and copy this down if you need. So we follow these rules when multiplying or dividing. You'll have two numbers to multiply and divide. If they both have the same sign, meaning both are positive or both are negative, the answer is positive. And if they have a different sign, the answer is negative. So what do I mean by that? Well, let's just say I have something simple like -7 times 2. Well, what that means is -7 plus to itself, because when you times something by 2, you're adding it to itself. And from what I learned on the previous slide, -7 plus -7 will just be -14. You can use a number line if you need. So what I could have done to get here a quicker way is I could have just multiplied 7 by 2 to get 14 and decided whether my answer should be positive or negative. So 7 times 2 is 14. Now, because only the 7 was negative, the answer is negative. So let's look at some other examples. So let's say I have -8 times -3. So what I do is I forget about the signs. I just do 8 times 3 is 24. Now I decide, is my answer positive or negative? Well, because both numbers here are negative, they have the same sign, the answer is positive. Let's say I have -7 squared. So -7 squared means -7 times -7. So what that means is I just times 7 by 7 to get 49. and I decide if my answer is positive or negative. Now, once again, both numbers were negative, so my answer is positive. So please remember this. Whenever you square a negative number, the answer is still positive. So let's just rub these off. Please pause and copy down if you need, and we'll do a few divisions quickly. So let's say I have minus 12 divided by 6. So forget about the signs. 12 divided by 6 is 2. Now I decide is my number positive or negative. Now here, the numbers have a different sign. This one's negative, this one's positive, so my answer is negative. Similarly, if I had something like this, minus 63 over 7, this means minus 63 divides 7. 63 divides 7 is 9. Now, only the top number, only one of the numbers is negative, so the answer is negative. If I have minus 28 divided by negative 4, so I go 28 divided 4 is 7. Now, because they both have the same sign, both numbers are negative, this time the answer will be positive. So what number would I need to put in the box if I have something like this? If I say minus 8 times some number gives me 96, what number would go in the box? So if you're doing one of these, forget the signs for a second. So what do you times by 8 to get 96? Well, you can figure that out. Just 96 divide 8, and that's 12. Now, because this is negative and this is positive, this number in the box would need to be negative because two negatives multiplied together make a positive, okay? Negative times negative equals positive. Negative times positive equals negative, okay? So the answer in the box has to be negative. If it was a positive 12, if I put a positive 12 there, my answer would be negative 96. So I can't do that. It has to be a negative 12 in the box. All right, let's look quickly at order of operations. So remember we did BIDMAS earlier in the year. We're just going to make sure we can apply it to calculations involving directed numbers. So this tells you the order in which you do things. You do anything in the brackets first, followed by index, which means raising things to a power, then division and multiplication. Remember, they're sort of the same. You do whichever occurs first from left to right, and similarly addition and subtraction, you do whichever occurs first from left to right. So if I have a calculation like this, minus 2 plus 7 times negative 3, multiplication is before addition, so I need to do this part first. So I leave my minus 2 alone. I'm showing my working out here. So 7 times negative 3, so I go 7 times 3, 21. Only one of the numbers was negative, so it's minus 2 minus 21, which gives me minus 23. So a similar story in this one here. I need to do multiplication before subtraction. So 8 times negative 2 is what I'll do first. I'll leave my 4 alone. 8 times negative 2 is minus 16. 4 minus minus 16. Remember, two negatives together make a plus. It becomes 4 plus 16, which I know you know how to do. So let's say we have a sum like this. We need to do the brackets first. So within the brackets, we have a couple of operations. Once again, multiplication needs to be done first. So to show my working out, next line equals, I'm leaving the minus 3 alone. I'm just doing the multiplication first. So 4 times negative 8 gives me negative 32 because one is positive, one is negative. Now you might be thinking, well, what about these brackets? Well, it's not actually asking me to perform an operation. It's just the brackets here are just making things a little easier to understand. So now I'm going to do the subtraction in the brackets. Minus 3 minus 32 gives you minus 35. So we start at minus 3, we go 32 to the left, we get more negative. So minus 35 divided minus 7, both of them are negative, so the answer will be positive. 35 divides 7 is 5. The answer is positive because both were negatives. All right, let's now look at substitution involving directed numbers. So we're now going to look at substitution, which is where you take an expression that has pronumerals or letters and you exchange their values for numbers. So I'm telling you x is minus 3, y is minus 8. So I'm going to ask, what is the value of, let's start with x plus 1. So here I'm just going to take my expression x plus 1, I'll write it again, and I'm going to get rid of my x and change it to minus 3. So minus 3 plus 1 is minus 2. So when I say what is the value of, your answer should always be one number only, and we're done. So the value of xy, so remember if no operation's written, it means times. So this means x times y, x times y. Like here, we've gone through this already. 3 times 8 is 24. Both numbers are negative, so the answer is positive. If I have something like x squared over y, that's a tough one. So on top we have x squared divided by y. So as I said to you before, whenever you square a negative, you always get a positive. So minus 3 squared is positive 9, and on the bottom is minus 8. So 9 over minus 8, you can leave it as a fraction just like that. So what would be the square root then of x squared minus 2y? This is a tough one. So what we're going to do is no different to what we've done before. I'll show you the substitution again. We're going to change x to -3. Now, whenever you're squaring a negative, it should be in brackets, because if you don't put it in your calculator with brackets, you'll get the wrong answer. So x squared minus 2y. Minus 2y means minus 2 times y. So I'm going to get rid of my y and replace it with a times -8, because y is -8. So this is the square root of 9. Minus 3 squared is 9, as we established before. Now, minus 2 times minus 8 gives me positive 16. So remember, order of operations, that's why I did this first, and then you worry about this. So I now need to do what's under the square root first. 9 plus 16 is 25, so this is the square root of 25, which is 5. Remember, square root of 25 says, what do I times by itself to get 25? So I know that last one was particularly hard, but we've got to be really good with substitution. All right, the last thing on directed numbers is the Cartesian plane. Please pause and copy this down if you need. So the Cartesian plane looks like this. So we have the same number line that you saw before, so red numbers are negative and green numbers are positive. This is just a normal number line. The Cartesian plane is actually two number lines that are sort of stuck together, that intersect each other. So we've got a number line going horizontally, left to right, and we call this the x-axis. So we're now going to construct another number line going up or down. So similarly, it has negative and positive numbers. So its negative numbers are the numbers below 0. They're actually physically below this time. So this would be -1, -2, -3, -4, and -5. And its positive numbers are now literally above 0. So 1, 2, and so on. So the arrows go on both number lines to indicate that they go on forever. Numbers never start or stop. So we call this vertical axis going up and down the y-axis. Your axes need to be labeled. So what we need to be able to do is plot points in this axis and read off the coordinates of points. So if we plot a point, let's say here, it has an x value and a y value. So this point here I'm going to call A. We're going to write its coordinates. So the x value, we think, if I start at the origin, this point here, 0, 0, where the two axes meet, how do I get to that point A? Well, I need to go 2 across. The x value of this point is 2, and I also need to go 2 up, so the y value is also 2. So this is how we write a point. In brackets, we always write x first and then y second. So the x value is 2, the y value is second. So you just need to write it like this. You don't need to write this. I just wrote it so you know what is going on. Always write the x value first. So let's say we had a point out here. So a point here I'm going to call B. So its x value, go down to the x-axis. Its value is -4. That value always goes first. X value is always first. And its y value is +1. So once again, we don't need to write a positive sign because 1 is understood to mean +1. So it's getting confusing if we just write points wherever. So we just put an A here to note A is the point 2, 2, and B is the point -4, 1. That's how you write the coordinates of points. You always need brackets and two numbers. First number is the x-coordinate and the second number is the y-coordinate. Now let's say you were asked to plot a point. So I'm going to plot a point C, and it's going to be the point 0, minus 5. So I want to plot this point. So the first value, remember, is always the x value, and the second is the y. So to plot this, I go to the origin, 0, 0. Okay, so the x value is 0. So that means I don't go across at all. I stay where I am. The y value is minus 5. So I go down to y value of minus 5, which is here. This point in green is the point 0, minus 5, and I put a C there to indicate that's point C. So that's how you write coordinates, which is what we did for A and B, and then also plot, which is what we did for C. All right, we're done with directed numbers, and now we're going to move on to shapes. So the shapes that we're looking at, we're just looking at different types of triangles in quadrilaterals. So we'll start with triangles. So we need to be able to classify types of triangles and also find unknown angles. So we start with classifying. So I've put the 3 types of triangle on your screen: scalene, isosceles, and equilateral. We classify triangles firstly according to whether they have no equal sides, which is scalene, 2 equal sides, we call that isosceles, and 3 equal sides, which means equilateral. So note, a triangle can't have 1 equal side. That doesn't make any sense. Now we call triangles, or any shapes for that matter, according to their vertices. So if these vertices, the corners, are ABC, this triangle is triangle ABC. And if, we label these vertices here X, Y, Z, this isosceles triangle, we just call it triangle XYZ, just to help with naming. So let's look at the triangle on the left. It is scalene. It has no equal sides. So it turns out that for any triangle, the number of equal sides is also the number of equal angles. So a scalene triangle has no equal sides. That means it has no equal angles. And that works for isosceles triangles and equilateral triangles as well. Isosceles triangles have 2 equal sides, which means they must have 2 equal angles, and equilateral triangles have 3 equal sides. That means they also have 3 equal angles. So for the isosceles triangles, these dashes here means that the sides are equal in length. We don't need to measure and check them. It turns out that it is these angles here that are equal. The angles where the sort of non-equal sides meets the equal sides. They're called the base angles. They're the ones that are always equal. In an equilateral triangle, all of them are equal. Now, it turns out for any triangle, all of those angles add up to 180. Label the angles in the scalene triangle D, E, and F. D plus E plus F, the size of all those angles adds up to 180. That works for any triangle, no matter how wonky it looks. So for the equilateral triangle, that means that all of its angles must be 60 because they're all equal and they add to 180 degrees. Okay, so we can differentiate triangles based on whether they have any equal sides and angles, or 2 equal sides and angles, or 3 equal sides and angles, but it doesn't matter which of these 3 types of triangles it is, the angle sum of any triangle is equal to 180 degrees. Now what this means is, if the angle sum of a triangle is 180 degrees, that means there's 3 possibilities for the angles in a triangle. A triangle can follow one of these definitions. It will either be acute angled, all its angles are acute; right angled, it has 1 right angle; or obtuse angled if it has 1 obtuse angle. Of course, because the angle sum of a triangle is 180, a triangle can't have 2 right angles or 2 obtuse angles. It can have at most 1 right angle and at most 1 obtuse angle. So in addition to classifying triangles by their side names, scalene, isosceles, or equilateral, we need to also classify by their angle names, which is one of these. So we need to not only determine, is a triangle like scalene, we need to determine, is it an acute angled scalene or an obtuse angled scalene? For an equilateral, because all its angles are 60, all equilaterals are acute anyway. So there's no real point for equilateral triangles. They're always acute angled. But for scalene and isosceles triangles, we need to be able to determine which type of scalene or isosceles they are. So let's look at a couple of examples where we go through this. So please pause and copy this down if you need. So in each of these, we will determine which type of triangle we have. So let's look at the first one on the left. Now we see that all three sides have a different length. So that straight away means that the triangle is scalene, no equal sides. However, we don't know which type of scalene it is yet. We need to determine, is it acute angled, right angled, or obtuse angled? Well, we see the largest angle here is 72 degrees. 72 is less than 90, that's acute. So this is an acute angled scalene, or you can just call it an acute scalene. Now for the next two, we're going to use the fact that the angle sum of a triangle is 180 degrees. That works for any triangle, remember. So in this next triangle, let's look at it. Well, we know it's going to be right angled because this symbol here means this angle is 90 degrees. So if we have a 45 degree angle, this one here, to figure it out, we just minus 90 plus 45 from 180. So 90 plus 45 gives you 135. So you figure out how much more do I need to go to get to 180. So 180 minus 135 is 45. So it turns out this angle here is also 45 degrees. So what that means is this has two equal angles, it's isosceles. So we know that it's right angled because of the right angle, and because it has two equal angles, it must have two equal sides. These two sides must be equal, so it is isosceles. So let's look at the third one. We know the third one is isosceles as well, so let's just write that. We know it's isosceles because we have two equal sides marked. This and this must be equal. So if this angle here marked is 30 degrees, then this one here must be 30 degrees, because remember, the base angles in an isosceles triangle are always equal. So what would be the third angle? Well, this angle here, again, 30 plus 30 gives us 60. And then we just subtract that from 180. How much more do I need to go from 60 to 180? And the answer is 120. So 120 is more than 90. This blue angle is obtuse. So this is an isosceles, but it is an obtuse angled isosceles, or just an obtuse isosceles. So remember, all equilateral triangles are acute angled, but scalene and isosceles, they could be acute angled, right angled, or obtuse angled. You need to give both the side an angle name. So it's good that we did these examples, because we also had practice in finding unknown angles, which is something else you need to be able to do. You do just what we did up there. You take the value of the two angles you know, subtract from 180, and you have the other angle. Now sometimes that gets a bit complicated. What if I had a triangle like this? So this one's a bit harder because I only have the value of one angle. So I have to again use the fact that it's isosceles to find the value of x. So I know because it's isosceles, two equal sides, this angle here must be equal to x. Those two angles marked with the arc, they are equal. So both of them must add up to 100, because 180 minus 80 is 100. They must add up to 100, so all three angles add to 180. So x, I'll just go 180 minus 80, divide 2, and that gives me 50. I divide 2 because they're the same and they add to 100. So this angle here and this angle here are both 50. They must be equal because the triangle's isosceles, and 50 plus 50 plus 80 gives us 180. So the last thing we need to do on triangles is exterior angles. Please pause and copy this down if you need. So for exterior angles of a triangle, the rule is that the exterior angle equals the sum of the two opposite interior angles. What does that mean? Let's draw a triangle, and I'm going to draw one side and keep it going, extend that side. This angle here I'm going to call X, the black one. It's called the exterior angle. It's outside the triangle. If I call these here W, Y, and Z, they are the interior angles. So green is the interior angles inside the triangle, and black the exterior angle. So what this statement up there says is the exterior angle, which is x, is equal to the sum of the two opposites. So opposite means facing, interior angles. So W and Y are both interior angles because they're inside the triangle, and they're opposite x, they're facing x. So x is W plus Y. So we can use this to find unknown values. So we're now going to find the value of x in each of these diagrams below. So for the first one on the left, so x is the exterior angle. It's just the sum of the two opposite interior angles. So here x is just 48 plus 42, which gives you 90 degrees. Just the sum, two opposite interior angles. So in the second one, note we're not actually finding the exterior angle this time. We're finding an interior angle. So I know that this angle plus 74, the sum of the two opposite interior angles gives the exterior angle. So you just have to think, what do I need to add to 74 to get 135? If you don't know, 135 minus 74, you get x is 61 degrees. Okay, because 61 plus 74 is 135. So if we look at the last one, note that the triangle in the picture is equilateral. So even though no angles are marked, we can figure them out. We know that this angle, and this angle are all 60 degrees because the angles inside any equilateral triangle are 60 degrees. So x is just going to be the sum of the two opposite interior angles, this one plus this one, 60 plus 60, which gives 120 degrees. All right, last thing we need to do now is quadrilaterals. Please pause and copy this down if you need. So just as we did for triangles, we need to be able to name and classify quadrilaterals. Now for triangles, we divided them based on whether they had equal sides and angles. Here we're going to divide the quadrilaterals into three groups based on whether they have 0 parallel sides, 1 pair of parallel sides, or 2 pairs of parallel sides. So it's easy if there's just 1 pair of parallel sides. Then the shape is a trapezium and it looks kind of like this. So these arrows here don't mean the sides are equal, they mean they're parallel. Now the trapezium is also called a trapezoid. It might look like this, but it's still a trapezium if it has 1 pair of parallel sides. So sometimes trapeziums have equal sides and you just call it an isosceles trapezium. So both of these shapes up here are an example of a trapezium. Now if a shape has no pairs of parallel sides, it's either a kite or an irregular quadrilateral. So a kite is basically a diamond. It looks like this. Now you need to know the properties of kites. Kites have 2 pairs of equal sides. So those 2 sides are equal and these 2 sides are equal. In a kite, adjacent sides are equal, so sides next to each other. So the angles where the non-equal sides meet, they are also equal in a kite. So sorry, you need to know all of these about a kite or a diamond. So if you have a shape that has no pairs of parallel sides and it's not a kite, it would be an irregular quadrilateral. So they're just those wonky looking things, you know. Could look like this. You've probably seen a few of these before. Could just be something that looks like this. Okay, it doesn't really fit into any other category. Both of these are irregular quadrilaterals. So we now look at the last group, 2 pairs of parallel sides, which is a parallelogram. So this is a little more complicated because there are actually quite a few types of parallelograms. So a parallelogram looks like this. 4 sides and 2 pairs of parallel sides. So this side and this side are parallel, and these 2 sides are parallel. Once again, the arrows mean parallel. It turns out that for any parallelogram, opposite sides are equal. So in a kite, adjacent sides next to each other are equal. In a parallelogram, sides facing each other are equal. So this is what a parallelogram looks like, but there are special types of parallelograms. So if a parallelogram has all angles equal to 90 degrees, it has a special name. So this shape here is a parallelogram. because it has two pairs of parallel sides, and of course that means opposite sides are equal, but also it means all its angles are equal. So this particular shape where all the angles are equal, you probably know, is a rectangle. So a rectangle is a type of parallelogram. All rectangles are parallelograms because they have two pairs of parallel sides. But not all parallelograms are rectangles because not all parallelograms have all their angles equal. So if a parallelogram has all its sides equal, it has another special name. So once again, this blue shape is a parallelogram because it has two pairs of parallel sides. Parallelograms don't need to have all of their sides equal to each other. When they do, however, we give it a special name. If all of these sides here are equal to each other, we call it a rhombus. So a rhombus is a parallelogram. It's also like a kite because it has equal angles here and because adjacent sides are equal. So a rhombus is a type of kite and also a type of parallelogram. In any parallelogram, opposite angles are always equal. So these two are equal and these two are equal as well. And a rhombus has that too. It has these two angles being equal and these two angles being equal. So it satisfies the definition of a kite with the equal angles and the adjacent sides being equal. But it also satisfies the definition of a parallelogram because it has two pairs of parallel sides. So it turns out that if a shape is a parallelogram and has both those. So if we have a parallelogram that has all angles equal and all sides equal, you know this one very well. It's a square. So a square is a special type of parallelogram. It's a parallelogram because it has two pairs of parallel sides. It has all its angles equal to 90 degrees, so it's a rectangle, and all its sides are equal to each other, making it a rhombus. So a shape that is both a rhombus and a rectangle is a square. So a square is a type of rhombus, a square is a type of rectangle, and it's also a type of parallelogram. So you need to know these definitions to be able to determine when you're given a quadrilateral what type of quadrilateral it is. Let's just look at a few quick examples of this. You're given a shape like this. It's a quadrilateral because it has four sides. Now, because opposite sides are equal, it must be a parallelogram. So make sure you can spell these properly as well. So parallelograms need to have two pairs of parallel sides, don't they? Well, it turns out if the opposite sides are equal, they will also be parallel. So this shape is definitely not a rhombus because not all of its sides are equal. We can't say for sure it's a rectangle because we don't have any reason to know whether or not each of these angles here is 90 degrees. We know, however, that these two angles will be equal and these two angles will be equal. We just don't know if they're 90 degrees. So because of what we said, if you get a four-sided shape and you're told all sides are equal, you can't be sure it's a square. We know it's definitely a rhombus because any four-sided shape with all sides equal is a rhombus. We don't know if it's a square because, once again, we don't know if each of its angles are right angles. All right, now we're going to move on to finding missing angles in a quadrilateral. Please pause and copy this down if you need. So for any quadrilateral, even if it's a wonky looking one like this will be a quadrilateral because I'm going to draw it with four sides. It always has the same angle sum. That's because you can always divide it into two triangles. So these three yellow angles must add to 180 because the angles in any triangle do. And then these three angles in green must add to 180 because the angles inside any triangle add to 180. So we've got 180 plus 180. For that reason, the angle sum of any quadrilateral is 360 degrees, and we can use this to find unknown angles. So we're going to use this now to find the value of x in each of these diagrams below. So let's find x in the first one. So we know all four angles inside this quadrilateral add to 360. So 20 plus 30 plus 15, the three angles we know, if I add them up, I get 65 degrees. So I need to find x by saying, what do I need to add to 65 to get to 360? So it's just going to be 360 minus 65, which gives you 295 degrees. So, of course, in a quadrilateral, you can have an angle over 180, whereas you couldn't in a triangle. Let's look at the second one. So this is hard because we only have two angles. What we need to do is use the property of a kite to find x. So remember, this is a kite because it has two pairs of adjacent sides being equal, has no parallel sides. So this angle here, x, and this angle here are equal. So 60 plus 40, we know that that is obviously 100. So what that means is the two yellow angles must add to 260, so that all of them add to 360. So x will just be 360 minus 100, 260 divided by 2. So each of those yellow angles is 130 degrees, because 130 plus 130 plus 60 plus 40 gives you 360. And the angle sum of any quadrilateral is 360. So let's look at this last shape. It's a parallelogram because it has two pairs of parallel sides. So I know straight away this angle here is going to be 80 degrees. And this angle up here is going to be x. How do I know that? Opposite angles in a parallelogram are always equal. So 80 plus 80, let's add the angles we do know, that is 160. So that means that this angle here, x, and this angle here add to 360 minus 160, because 80 plus 80 is 160. Each of them will be 360 minus 160 divided by 2. Each of them will be 100 degrees. Okay, how easy is that? So the very last thing I need to go on this video, and I promise I'll be quick, is convex versus concave quadrilaterals. Once again, please pause and copy this down if you need. So to determine whether a quadrilateral is convex or concave, you just ask any of these questions. Are there any reflex angles? Is there a vertex pointing towards the center of the shape? Or is there a diagonal that lies outside the shape? It turns out the answer will either be yes to all of these or no to all of these. If it's yes, the shape's concave, and if it's no, the shape's convex. So let's look at examples. So we have two quadrilaterals here. The first one is concave and the second convex. So let's go through the question. So for the first one, are there any reflex angles? Well, yes. Concave shapes have a reflex angle like this. This angle is more than 180 degrees, making it reflex. Convex shapes do not have any reflex angles. Secondly, we're looking at vertices. Note, remember, vertices means each of these corners. So this vertex here, this one here, is pointing towards the center of the shape, which is about there. So it's concave. Whereas if you look at convex, all of the vertices, this one, they're all pointing away from the center of the shape. They're all pointing outside the shape. For the last one, note diagonals are lines that join non-adjacent vertices. So for the concave shape, this is actually a diagonal, this yellow line here, and this is also a diagonal. See, the second diagonal is outside the shape, whereas for a convex shape, the lines that join non-adjacent vertices, this is a diagonal and this is a diagonal. So you can see the concave shape has a diagonal outside the shape, whereas the convex does not. So that's why you can use any of these three questions to determine whether a shape is concave or convex. Now, concave, it sort of looks like it's been caved in here. So that's where we get the name concave. It's been caved in. Now, note that the shape on the right, two pairs of parallel sides, is convex. Most of the quadrilaterals you encounter are convex. In fact, all the special types are trapeziums, parallelograms, which means rhombuses, squares, rectangles, also kites. They are all always convex because the answer is no to all of these questions for any of those shapes I just mentioned. If a shape's concave, it must be an irregular quadrilateral. There's no way it can be a parallelogram, a trapezium, or a kite. All right, sorry for the long video. Best of luck studying. You're a superstar, though. You're going to ace it. First few people in my class who come up and say Caramello Koala, you can have one for watching this video. Thank you so much. This has been the luckiest maths teacher in the world. Have a great day.